Hello, my name is Nina Mormon, and today I will be presenting work titled Impacts of Robot Learning on User Attitude and Behavior. The world's population is aging, and many older adults will require physical and cognitive assistance as they age. Yet there is a growing shortage of nurses, caregivers, and assisted living facilities, inducing frequent caregiver burnout. One solution is to develop in-home robots that can provide assistance and enable aging in place. Care robots provide caregiving assistance and can alleviate the burden on care providers and enable care receivers to maintain independence longer. However, deploying a robot that is fully capable into an unstructured residential environment is difficult. The type of task and the way in which the task is done may need to change over time as the user ages or the environment changes. Additionally, different users may want the same task done differently. Thus, it can be beneficial for robots to be able to learn new tasks directly from their users and perform behavioral customization on-site. Because this robot learning will likely be visible to the end user and can even involve that user, the way in which the robot learns may have an impact on the end user's perceptions of the robot. We investigate how the method of learning, broken into conditions representing differing degrees of user involvement in the robot learning, impacts perceptions of the robot. These differences between robot learning methods may alter an end user's perception of the robot and affect adoption. We investigate how observing robot learning impacts an end user's perception of a robot. The four learning conditions are as follows. In the download condition, the robot downloads knowledge from the cloud about how to do the task. In the reinforcement learning condition, the robot learns the task through trial and error. In the interactive learning condition, again the robot learns through trial and error, but this is supplemented with feedback from a human teacher labeling the robot action as good or bad. Finally, in the learning from demonstration condition, the human teacher physically manipulates the robot to show it how to accomplish the task. We investigate three research questions in this work. First, we investigate how the method of robot learning impacts an end user's perceptions of the robot. Second, we investigate whether robot perceptions differ between the general population and caregivers. We conduct our study with both caregivers and the general population. However, COVID-19 limits our in-person interactions with caregivers. Therefore, we choose to conduct our study with caregivers remotely. However, prior work has shown that physical presence impacts user perceptions of the robot. In order to avoid confounds of caregivers being remote and the general population being in person, we evaluate the general population both remotely and in person. Therefore, in our last research question, we investigate the role of physical presence on user attitudes and behavior with respect to the robot. Our study design has two phases. First, the participant observes a video of the robot learning how to accomplish a task. This video is unique for each learning condition. We note that we employ Wizard of Oz policies for each learning condition's behavior. We choose to employ Wizard of Oz policies in order to keep performance constant between learning conditions and in order to isolate the impact of the learning method independent of failure rate. Next, the participant observes the robot use what it has learned to accomplish a similar test task. The participant is given the choice of intervening during the testing phase. The overall task of this study was to prepare a breakfast plate. The two subtasks included dispensing medicine from a cup onto a plate and cutting a banana on the plate using a knife. In terms of metrics, we collect both objective and subjective metrics. Our objective metric is intervention, where participants are allowed to stop the robot if they feel unsafe or uncomfortable or if the robot makes a mistake during the testing phase. We collect a series of subjective metrics, including but not limited to usability and acceptance, trust, task risk, perceived success and safety, and anthropomorphism. We find that observing the robot learning impacts perceived anthropomorphism, and that higher user involvement in robot learning corresponds to lower anthropomorphism. We additionally find with a large effect size that perceived success impacts reliability, trust, and ease of use, though learning condition does not. We thus posit that users may prioritize a robot learning method that is more competent over a latent user preference across interaction modalities. Prior work has shown that caregivers feel favorably regarding robot usability and intent to future use. In our next research question, we seek to understand how the general population feels about care robots learning and how this may differ from how caregivers feel about care robots learning. We thus examine how the general population's attitudes differ from that of caregivers. We find that caregivers are more critical of robot success on a medicine-related subtask, and equally critical of robot success on a physical manipulation task of cutting a banana. However, despite the lower perceived success of the robot on the medicine-related task, we note that we do not find differences in intervention rates between caregivers and the general population on either subtask. Some notable quotes obtained from our remote caregiver participants are, "Scary when it selected the wrong medication, unless I read it wrong. That could be deadly. The robot performance was very non-deliberate, and there are risks associated with malfunction." And finally, "I should have intervened when the robot mistakenly put morphine on the plate instead of the antibiotics. I think that I would not at this time use a robot." Lastly, we investigate the impact of physical presence on robot perceptions. We find that in-person participants report more favorably than remote participants on a wide variety of subjective metrics, including perceived safety, reliability, ease of use, attitude, intent to use, and trust in the robot. This highlights the need for researchers to consider physical presence in study design. Limitations of this work are that we do not yet include care receivers and limit the scope of this current study to care providers. In future work, we would like to bring in care receivers into recruitment. Secondly, we would like to increase the sample size of our target populations, including both care receivers and care providers. And lastly, we would like to increase the diversity of our general population. In terms of future work, we are interested in investigating the differences in robot learning when not implementing Wizard of Oz policies, rather implementing the actual policies of the robot learning. This way we could determine how differences in failure rate, training time, and resulting behavior impact perceptions of the robot. To summarize, we find that firstly, when presenting robot learning, the performance of the learning method appears to be more important than the degree of user involvement in the learning process. Secondly, we observe lower perceived robot success on the medicine subtask for care providers. However, this does not appear to translate into higher interruption rates. Finally, we find that physically present robots are more favorably perceived. Thank you very much for listening.